Hi everyone, myself Siddharaju, Assistant Professor of Chemistry. Here I am going to discuss about alkanes. It is for the BSc first semester and title of the paper is Chemistry 1 DSc 2A. In this session, I am going to discuss particularly about the mechanism of oxidation of alkenes with osmium tetroxide, mechanism of oxidation of alkenes with potassium permanganate, mechanism of ozonolysis of alkenes, and industrial applications of ethene and propene. Let me consider one by one. The first one is oxidation of alkenes with osmium tetroxide. Osmium tetroxide is a useful oxidizing agent which is used to oxidize the alkenes to vicinal diols through syn addition. Let me take an example. Here I have taken cyclopentene. When it is made react with osmium tetroxide in the presence of hydrogen peroxide, it converts into vicinal diol. Then how does this reaction proceeds? Let us have a look at the mechanism. This reaction proceeds through a concerted process whereby the two oxygen atoms of the osmium tetroxide interacts with the pi electrons of a multiple bond, and it results an intermediate. It is a 5-membered ring is called osmate ester. The osmate ester so formed is oxidized by using hydrogen peroxide and gets converted into a vicinal diol. Here we can also use sodium bisulfite instead of hydrogen peroxide. Let us consider one more reaction, oxidation of alkenes with a potassium permanganate. Potassium permanganate is a strong oxidizing agent when compared to osmium tetroxide. It also oxidizes alkenes to vicinal diols. So the glycol initially formed is further oxidizes. So in case of osmium tetroxide, there is no further oxidation of diols. But here potassium permanganate further oxidizes the glycol formed. So during the oxidation, the disubstituted carbons become ketones, monosubstituted carbons become carboxylic acids, and terminal CH2 having double bond becomes carbon dioxide. Let me consider a reaction. So you take cyclohexene. When it is made react with a potassium permanganate in cold condition, this is very important, in cold condition it get oxidizes to vicinal diol. Then how does this reaction proceeds? Let us have a look at the mechanism. So this reaction also proceeds through a concerted process whereby the two oxygen atom of the permanganate ion interacts with the pi electrons of a multiple bond. It is a syn addition to give this intermediate. So this intermediate being attacked by a nucleophile, that is OH minus, and it gives this compound. So here the breaking of this cyclic intermediate occurs to give this species, and protonation takes place to give a negatively charged ion, and it abstracts a proton from the H3O plus and gets converted into vicinal diol. So there is one thing to be careful about using potassium permanganate for the oxidation of alkene is it breaks the carbon-carbon single bond of this glycol, and it may proceed further oxidation to get converted into a carbonyl compound. So to avoid this, the reaction must be carried out in a basic condition at a low temperature. If not, the reaction will goes like this, that is oxidative cleavage by potassium permanganate. See here, the two oxygen atoms of the potassium permanganate interacts with the pi electrons of a multiple bond in a syn fashion, and it gives an intermediate, and it undergoes oxidative cleavage. So breaking of cyclic intermediate to give an aldehyde, which undergoes further oxidation to convert into a carboxylic acid. So it is very important that during the oxidation of alkene using potassium permanganate, we have to maintain the basic condition and we have to carry the reaction at low temperature. Then one more interesting reaction is a ozonolysis. So ozone will oxidatively cleave the double bond to produce aldehydes and ketones. Ozone is a milder oxidizing agent than the potassium permanganate, and it will not oxidize aldehydes formed. So let me have a look at this reaction. I have taken an alkene. When it is made react with a ozone in the presence of dimethyl sulfide, it converts into ketone and aldehyde. See, this portion will convert into ketone and this portion will convert into aldehyde. Then how does this reaction proceeds? That is the mechanism. See, look here. Here I have taken one of the resonance structure of a ozone which attacks the multiple bond of a alkene, and it forms primary ozonoid. So this primary ozonoid formed undergoes rearrangement to give a ozonoid. So once the ozonoid is formed, it made react with a dimethyl sulfide and gets cleaved into a ketone and aldehyde along with the formation of dimethyl sulfoxide. So here, instead of dimethyl sulfide, we can also use zinc. It gives the same result. Now, let us consider industrial applications of ethene. So ethene is one of the important compound widely used in the industry for the production of the following compounds. See, ethanol, it is produced from the ethene, which is used as a solvent, and it is also used in the preparation of esters. And one more important compound obtained from ethene is ethylene oxide. It is an industrial solvent. So it is also used in the production of ethylene glycol, which is used as an antifreezer, and it is also used in the production of Dacron. And one more industrially important compound that can be obtained from the ethene is vinyl chloride. It is used for the production of PVC, polyvinyl chloride. And it is also used in the production of vinyl acetate. It has a wide industrial application in the production of paint emulsions, plywood adhesives, and it is used in textiles also. And one more interesting compound that can be produced from ethene is polyethylene. It is used in the production of plastic bags, toys, etc. Now let us consider one more industrially important compound, that is propene. It is used in the production of these compounds. So isopropyl alcohol, it is one of the industrially important compound. It is used as a rubbing alcohol. It is widely used in cosmetics, and it is used in the synthesis of acetone. And one more industrially important compound from the propene is propylene oxide. It is used in the manufacture of polyurethanes and polyesters. And cumene, it is one more industrially important compound. It is used in the preparation of phenol and acetone. And polypropylene, it is used in molded articles, kitchenwares, fibers for indoor and outdoor carpeting, etc. See, these are the things to be considered in this session. So far, I have discussed about the oxidation of alkenes by using osmium tetroxide, potassium permanganate, and I have discussed about the ozonolysis of alkenes and industrial applications of ethene and propene. Hope you understood the concepts. Thank you very much.